co-founder of Fast.ai, which is making deep learning more accessible and easier to use. I'm also a professor at the University of San Francisco Data Institute. And you can find me online at math_Rachel on Twitter or blogging at Fast.ai. And I decided to change the title of my talk because I think ethics often has connotations of being an abstract philosophy. And what I'm interested in is ways in which humans are harmed and are being harmed. My background, just briefly, I've loved math and computer science and algorithms for a long time, going back at least to high school. And I think for a while it was I liked the abstraction, and a lot of the appeal to me was just kind of these are really elegant and logical. I studied math and computer science in undergrad and then did a PhD in math. I later kind of, and I knew there were applications, but it's really not been until the last few years. So I worked as a quant and then a data scientist and software engineer, and just seeing more and more like this stuff is really powerful. And then I'm like, no, it's even more powerful than I realized, both in positive and negative ways. And so, yeah, this evening I want to talk about, I think, some misconceptions that lead to harmful uses, and what are some positive examples of people and companies doing things well, and what are some healthier principles for just even how we think about this. And hopefully there'll be some time for a few questions at the end. So the first misconception, and so all these misconceptions I think you hear both in tech and in AI in particular, and AI is it's such a particularly high impact area. The first misconception that I hear somewhat often is the idea that as engineers, we're just responsible for our code and not for how people use it. There's an analogous one with data scientists, that we're just responsible for our algorithm and not for the data quality or how it's implemented. So one example of this comes from The Verge did an investigation earlier this spring on software that's used to determine healthcare benefits, and it's used in over half of the 50 states. And they profiled kind of what happened when it was rolled out in Arkansas. And a lot of people had very sudden cuts to their benefits, including Tammy Dobbs, who has cerebral palsy. She needs a home health aide to help her get out of bed in the morning, to eat breakfast, to do a lot of basic everyday tasks. And her hours of help per week were cut by 20, so a huge cut. And she didn't get any explanation as to why or any process for how to appeal it. And she says she really flipped out when she heard this. And this happened to a number of people. In the article, they interview the creator of the algorithm. This is a professor at the University of Michigan. He's earning royalties off of this software. And they ask him, should there be a best practice of how you notify people of changes? And he says, yeah, we should probably have one. I should also probably dust under my bed, which is a really, I think, callous and dismissive response. And then he later says that he thinks it's somebody else's responsibility. He blames the kind of policymakers in Arkansas for the way that they rolled out the algorithm. Through a lengthy court case, it's eventually revealed that there were bugs in the software implementation that had made mistakes in calculating the number of hours for people with cerebral palsy or with diabetes. So it impacted a large number of people. And so this is a problem that's not unique to tech. So there's a bit of this like passing the buck of, like the creator of the algorithm is saying like, oh no, it's the policymakers, and the policymakers can say, oh no, it was about the software implementation, and I'm sure the software implementers of the software had someone they could blame. And Dana Boyd gave a keynote at Republica called How an Algorithmic World Can Be Undermined. And she points out that bureaucracy has often been used to evade or shift responsibility, because in a complex system, who do you hold responsible? And she gives the example of Nazi Germany during World War II. A lot of Nazi officials were bureaucrats, and they saw themselves as just, fulfilling their responsibilities, and not as, this like little piece of the system, and not seeing themselves as responsible for the Holocaust. And so this is a problem that's not been invented by tech, but that tech can make worse. Dana argues, and I agree, that today's algorithmic systems are often kind of used to extend bureaucracy. And so we have to think about this issue of like, how do we create systems in which people are able to feel responsibility for what's happening? So a very famous example of a biased algorithm is the COMPAS recidivism algorithm. And this is used to predict whether someone who's committed a crime or is suspected of committing a crime will commit another crime. It's used in deciding who has to pay bail. It's also used in sentencing decisions and in parole decisions. ProPublica did an investigation 2 years ago that discovered that the false positive rate for black defendants was 45%, compared to a false positive rate of 24% for white defendants. So this is a huge, huge discrepancy. Last year, the Wisconsin Supreme Court upheld the use of this algorithm. As a kind of side note, there's a very interesting field around definitions of fairness. Arvind Naranyan, a professor at Princeton, has given an excellent talk on 21 definitions of fairness, although I don't know of anyone outside of COMPAS who thinks that this is a reasonable definition of fairness to be using here. Earlier this year, research from, and I should note about the COMPAS algorithm that race was not explicitly a variable. And so race and gender are latently encoded in a lot of other variables in the US, and I'm sure in many countries. And so even if you're not explicitly recording race, you can still end up with algorithms that are very biased with respect to race. So earlier this year, there was a Dartmouth study that found that this algorithm is not more accurate than random people on the internet. They compared it to Mechanical Turk Workers, which is an Amazon service to get kind of people around the world earn small amounts of money doing tasks online, and this algorithm was not any more accurate. They also compared it to a linear classifier on 2 variables and found that it was not more accurate. So this is a proprietary black box algorithm with 137 variables, did not perform better than a linear classifier on 2 variables. And this is a strong argument for also why you should always have a strong baseline to know what good performance is before you start creating a machine learning model. One of the things that often makes these algorithms very hard to contest in court is that they typically companies protect how they work as a trade secret, and so it can be hard for lawyers to even kind of argue about the details because they don't know them. So I think a healthier principle for thinking about these is that we have a responsibility to think about the whole system, because our code is often interacting with very messy and complicated real-world systems, and we need to understand what those systems are and how the technology we create can exacerbate underlying problems. So there are a lot of underlying problems in the US criminal justice system that weren't created by COMPAS, but COMPAS can be and is, interacting with those, and we need to understand that. So as a positive example, I want to highlight this workshop that was held at the Fairness, Accountability, and Transparency Conference. Christian Lum, who has a PhD in statistics, organized a session together with a public defender who had worked in New York City and is now a staff attorney at the New York Legal Aid Society, as well as with an innocent man who was unable to afford bail. So in the US, 500,000 people are in jail because they're too poor to afford bail. This is before they've even had a trial. And the public defender and this innocent man were able to shed a lot of light on kind of how the criminal justice system works in practice. So the man had been held at Rikers Island in New York. The public defender shared that she had to take a bus 2 hours each way and would only be allowed to meet with the defendant for 30 minutes, and that's if the guards brought him in on time. They talked about how many innocent people accept guilty plea bargains just to get out of jail sooner when they're kind of spending all this time in jail before even getting a trial. And so it was really illuminating, and I think it's great that this was offered, and we need more of this, of kind of talking to the domain experts in the areas that we're working in and talking to the people who are impacted by the systems that we build. So the second misconception, I should take a drink of water, that I frequently hear is that humans and computers are interchangeable, and you can kind of just replace humans with computers in this very interchangeable plug-and-play way. And this was an underlying assumption of an article in Harvard Business Review a few weeks ago that was entitled, "Want Less Biased Decisions? Use Algorithms." And I wrote a response, what HBR gets wrong about algorithms and bias. But one of the key things that I think this article overlooked, and it is true, humans are very biased as well, but algorithms are often used very differently than human decision makers, and it's important to keep that in mind when thinking about these systems. So as one example, algorithms are more likely to be implemented without an appeals process in place. And so we saw that earlier with this algorithm that was used to determine healthcare benefits. Another example that comes from Cathy O'Neill's book, Weapons of Math Destruction. And Cathy O'Neill has a PhD in math. She previously worked as a quant and a data scientist. And she talks about a public school system in Virginia that implemented a computer system to determine which teachers to fire. And so there was a teacher that was beloved by her students and their parents and by the principal, and she gets fired and doesn't get any explanation as to why. So she doesn't know the underlying reason, and she also has no way to appeal it. And I think this is very, very Kafkaesque that this could happen. And it's even scarier to think about combined with the fact that algorithms are often used at scale. And so if we're thinking about a biased computer program used for hiring, you could have someone that, if they trip whatever biases, may not be able to get hired anywhere. And people are starting to use algorithmic systems for hiring, often in kind of lower wage, lower skilled jobs. Algorithmic systems are cheap, and often they are being implemented as a cost-cutting measure, and I think this also relates back to the being less likely to offer appeals. Human appeals are expensive. And then finally, the results from algorithmic systems are often viewed differently. So in the case of COMPAS recidivism algorithm, judges are just receiving it as a guideline. They don't have to necessarily follow it. But we have to look at what happens in practice of, do they feel comfortable overriding it? Are they going to get any negative feedback if they're frequently going against the algorithm? I think that I assume many of us in this room have a good understanding of probability and confidence intervals, but the general public does not. And so you have to keep in mind that many people are going to take a computer system or they're going to see it as being more objective and error-free and won't necessarily understand probabilities even if you provide them. And Cathy kind of captures many of these ideas under the idea that the privileged are processed by people, the poor are processed by algorithms. And I think that kind of shows up in this idea of doing things cheaply and at scale, and that where these systems are being implemented now are often among the poor, whereas people with more privilege and more wealth are more likely to get personalized attention. Another issue that I have with the concept of seeing humans and computers as interchangeable, as I see this as a variation on the idea that humans versus computers were competing. The media uses this framing a ton. And sometimes it's helpful, like it can spur research, humans playing computers at Go or at Dota. But I think it's of limited use in many real-world contexts. Because ideally, we should be asking, how can humans and computers best work together for better outcomes, leveraging the strengths of each? And I often see people trying to automate a particular kind of narrow task that a human does, but not thinking about the whole system of how is that going to be implemented, and are there ways that we can semi-automate things to better take advantage of what humans are good at. And so I think it requires kind of stepping back and thinking about how can we get the best outcomes. And then a third objection that I have to the humans and computers are interchangeable is that I think it downplays all the human components in algorithms. So there are a lot of human decisions in terms of what data to use and how that data is gathered, design decisions, choosing what to optimize. There's a very human component to our code and to our algorithms that you don't have something that's totally separate from humans. An interesting example comes from this paper by Shreya Shankar et al. And so Open Images is a data set released by Google that has 9 million images in 19,000 categories. It's the largest open image set out there. And ImageNet is by far the best studied image data set. ImageNet was the kind of subject of a series of competitions that really pushed the state of the art in computer vision and are part of why we're having this deep learning renaissance, is research that came out of ImageNet. So they've been very valuable. Shreya and her group looked at where the images come from. And so I'll go through the chart on the right, which is for ImageNet. The yellow part is the US. So 45% of the images are from the US. 7.6% are from Great Britain, that's in green. 6% are from Italy. 3% from Canada. Another 3% from Australia. 2.5% from Spain. So you'll notice we've covered over 2/3 of all the images in the data set, and I've only listed Western countries. So this is a really limited slice of the world. And so there's a lot of things that we can be missing. And it's similar results for open images. There are slightly more, or there are fewer images from the United States, but there are more images from Great Britain. It's still a largely Western composition. And Shreya and her group looked at grooms in particular. So a man getting married, they found that Western images of men getting married were well classified, but images of grooms from India, Pakistan, and Egypt, there was a much higher error rate. And this makes sense because there are a lot of cultural differences, but I think there are probably a lot of other differences that will only be detected in the future of how many things are going to be off because so much computer vision study has been done on this very, very Western data set. So a positive development and a possible way to try to address this is a paper called Data Sheets for Data Sets that Timnit Gebru et al. Published earlier this year. And Timnit has her PhD in computer science from Stanford. But prior to that, her background was in electrical engineering. And in electrical engineering, any component, so any circuit or resistor or transistor, comes with a data sheet. And the data sheet tells you, when and how it was manufactured, under what specifications is it safe to use, and gives you this information. And so Timnit proposed doing this with data sets as well. And the paper offers kind of a lengthy list of potential questions that could be answered on these data sheets. They include things about the motivation for why it was created, how it's composed and maintained, who supports it, what are the legal and ethical considerations. And so I really like this idea, and I think it really illustrates a lot of the human components that go into building a data set. Because we often think of data as being kind of more dry and objective, but all these human decisions have been made around it. And I'll come back to this paper. Something else I love about it is it has 3 case studies of how standardization came to different industries. And another drink of water. So the third misconception that I hear frequently is that regulating the tech industry will be too hard, it's too complicated, it's never going to work. And so I want to talk about 2 case studies. So one is the genocide in Myanmar. Earlier this year, the UN ruled that Facebook had played a determining role in the genocide, and a UN investigator said, "I'm afraid that Facebook has now turned into a beast." So 700,000 people who are part of an ethnic minority have been pushed out of their homes. Entire villages have been burned down. They're sharing stories of executions and rape. This is kind of huge, huge crisis. And people were trying to warn Facebook about this as early as 2013. So people warned Facebook executives in 2013, 2014, and 2015 of how Facebook was being used to incite violence and spread hate speech about this ethnic minority. One person who was involved said, "This is not 2020 hindsight. The scale of the problem was significant, and it was already apparent." And in fact, in 2015, someone who met with Facebook executives said he explicitly compared the potential to, Facebook can be in Myanmar what radio broadcasts were in Rwanda during the Rwandan genocide. And the radio broadcast by an extremist group played a very pivotal role in the Rwandan genocide. And Reuters did a very kind of lengthy investigative article earlier this week. Facebook is still struggling to deal with this. This came up this spring during the congressional hearings with Mark Zuckerberg, and he said that Facebook has added dozens of Burmese language content reviewers. And in contrast, even, again, there was escalating violence going back to 2012 or 2013. Even as of 2015, Facebook only had four contractors that spoke Burmese working on this. So I want to contrast this now with Germany. Last year, Germany passed a stricter hate speech law. Facebook could have faced fines up to $59 million. Facebook hired 1,200 people in under a year to work in Germany to address hate speech in German because they could have been fined $59 million. And so I'm not arguing that the German law is a model that we should follow at all. I just want to show the contrast of 5 years of people warning them about genocide versus the threat of a financial penalty. And this contrast between hiring dozens of people and hiring 1,200 people. So we've seen kind of an example of one thing that Facebook does respond to. Sorry, that's heavy. We can also look at other industries for examples of regulation. I think it's easy to focus on regulations that don't work and that are stupid, and to take it for granted a lot of regulations that have worked well. And so Data Sheets for Data Sets talks about the electronics industry, the pharmaceutical industry, and car safety. And there's also a great 99% Invisible, which is a podcast I like, did an episode called The Nut Behind the Wheel about the car safety. And so there are a lot of things that we take for granted now. When cars were first introduced, there were no speed limits, there were no seat belts, there were no traffic lights, there were no laws about not driving drunk. I don't think there were licenses. There were also, I didn't realize this, the windshields were made out of just regular glass, so it would shatter very easily in accidents and in a harmful way. There were sharp metal knobs on dashboards that would become lodged in people's skulls in the case of an accident. Non-collapsible steering columns would frequently impale drivers. The implementation of the collapsible steering column is credited with saving 80,000 lives. And there was also a widespread belief that this was kind of inherently how cars were. And, cars don't kill people, people kill people, they're dangerous, people are dangerous, and we can't solve or fix that. And so even the topic of getting people to think about how could we design or make cars differently was a tough one. And consumer safety advocates worked on this for decades. One of the kind of big victories that they won that was difficult to persuade is car companies wanted to suppress data about car accidents, and consumer safety advocates were able to get a law passed that just required that data to be collected. In this database, this is very comprehensive data of what happens in every car accident that occurs, and it's been hugely useful, and it's super useful to car companies now to be able to see, what are the dangerous parts and what can be improved. Another, I think it's a really kind of fascinating case study. A point that Data Sheets for Data Sets shared that I didn't know is that in collisions of a similar impact, women were 47% more likely to be injured than men. And this is in part because crash test dummies are based off of the prototypical male. And it was not until 2011 that a law was passed saying that they should also test female crash test dummies in cars. And this is, I think, just a really illustration of how bias can seep into these processes. That they had crash test dummies, but they were for men. So this is, I think, a very interesting case study. So when I talk about ethics with people, I often get a response of, you're not going to find ethical rules that everyone agrees on. There's no global maximum on ethics. So kind of why bother? Like there's ambiguity, and people are going to disagree. And I even sympathize with this viewpoint. In college, did not like humanities and social science classes because they were just not as clear cut. In math, like I can tell when a proof is correct. In computer science, you can tell when your code is outputting the correct result and running properly. And that's not the case in a lot of the social sciences and humanities. But they're addressing really, really important problems, and we can't shy away from hard and messy problems. And even if there's not a absolute correct ethics code that everybody's going to agree on, we can still see things that are working better and worse, and things that are leading to better or worse outcomes. And so the final misconception that I want to address is, and it comes up in variations, it's basically along the lines of, well, tech is just reflecting reality. So when I talk about bias, people will say, the world is biased, and tech just reflects that. When I talk about YouTube promoting white supremacy, people will say, people want to talk about white supremacy and share content. This is just reflecting the world. And I think that's not quite the case. So when we think about recommendation systems, and this can be anything, so YouTube has an up next where it makes recommendations to you that autoplay and automatically start playing. Facebook and Twitter, having moved away from chronological timelines, they're making priorities about what to show you and what has lower priority in showing you. Renee DiResta, who is an expert in the areas of disinformation and propaganda, has said recommendation systems and collaborative filtering are never neutral. They're always ranking one video, pin, or group against another and deciding what to show us. And I think that's important to keep in mind, and I think we would be having a different conversation if none of these platforms were making recommendations. So Guillaume Chaslot was an engineer at YouTube who worked on their recommendation system and has since left and been outspoken about some of the harms from it. He did an investigation together with The Guardian and the Wall Street Journal that found that when people searched for either Trump or Clinton, they were disproportionately likely, of the partisan material that was recommended, they were disproportionately likely to be shown anti-Clinton conspiracy videos, regardless of which they had started searching for. And he talks about a mechanism behind this. So he says, YouTube is trying to maximize how much time people spend watching YouTube, and they even say, I don't know if they've changed their statement, but say, if viewers are watching more YouTube, it signals to us that they're happier with the content they see. And a problem with this is that conspiracy theorists watch way more YouTube than the rest of us. And this is partly because I, and I'm sure most of you, have a variety of media sources that I trust and that I go to. And as a result, YouTube is not the only media source I'm using. And so YouTube's algorithm has learned that promoting conspiracy theorists is what will keep people on the platform the most. Guillaume has shared that YouTube recommended Alex Jones videos more than 15 billion times. And again, I want to make the distinction that this is not people searching for and seeking out Alex Jones videos. This is how much it was recommended to people that weren't searching for that. Zeynep Tufekci, who is one of the people I admire most, she is a professor at UNC and also writes for the New York Times. She was a research fellow at the Harvard's Berkman Klein Center. And she said, the number of people telling me that YouTube autoplay ends up with white supremacist videos from all sorts of starting points is pretty staggering. This needs large-scale and systematic research. And there's this Twitter thread of people responding to her with all these stories of, someone's like, I was researching leaf blowers and got recommended an Alex Jones video. Someone else was trying to teach his daughters about Nelson Mandela, and autoplay started showing some very racist, white supremacist material next. I've had people contact me to say they only use YouTube to watch machine learning videos, and they're seeing white supremacist videos being recommended. And this impacts society. Zeynep wrote in the New York Times, YouTube may be one of the most powerful radicalizing instruments of the 21st century. I want to offer a positive example now. We do not just have to optimize metrics. And actually, I guess I should say one more thing first. There's this idea of, I'll go back, the tyranny of metrics. And so anytime you have a metric, it's typically a proxy for the thing you really care about. So YouTube was using the amount of time people watch YouTube's videos as this proxy for happiness, which does not perfectly map to what happiness is. And there's an example, this does not involve computers, from the UK, of the UK started publishing the success rates of surgeons. So they were doing this to promote transparency. They want to encourage surgeons to have lots of success. A side effect of this was that surgeons started turning down particularly difficult or risky cases because they didn't want to hurt their success ratings. And so you had people that needed difficult or risky surgeries who couldn't find surgeons to operate on them. And this is always a risk when we place too much emphasis on metrics. So really want to commend Meetup for not doing this. Evan Estola is the lead machine learning engineer at Meetup. He gave a talk when recommendation systems go bad at MLConf Seattle. And he talks about how they realized at Meetup that fewer women were interested in tech meetups. And they realized that this could turn into a runaway feedback loop. They could recommend even fewer tech meetups to women. You might have fewer women attending tech meetups because they're not hearing about them. And so then the algorithm would learn to recommend even fewer tech meetups to women and create this really negative feedback cycle. And they chose not to do that. And so I think that's great. And in the long term, it's better to not just unthinkingly optimize for a metric, and we don't have to do that. Tech really has an impact on the world. We're not just meeting existing consumer demands. We're not just kind of reflecting what people already want. We're exposing people to new ideas. And we have a responsibility to not just optimize metrics, but to think about our values and to think about the broader system. And then I want to share the other reason I disagree with this is that I do want to make the world a better place. A little bit about my background. I grew up on the Gulf Coast of Texas near a cluster of chemical refineries. I attended a poor, predominantly black public high school that was later ranked in the bottom 2% of Texas schools. I was pepper sprayed by police while I was at school. And I could see as a teenager that the status quo was unfair to a lot of people. There were some great teachers and students at my school, but we clearly did not have the resources that wealthier schools had, and we were not treated the same. Later, I faced obstacles in graduate school. I experienced a lot of sexism and harassment. My thesis advisor even told me that I was too feminine to be successful, and later stopped meeting with me, which was devastating. And then even the switch into the tech industry and some of the problems I've encountered. And I say all this because I think I've worked hard and I've overcome obstacles, but I also recognize that I've been really fortunate and I've had a lot of opportunities that not everyone has. And so I want to say that about all of us. Less than 1% of the global population knows how to code. And the fact that we all know how to code, we know Python, or here in kind of this epicenter of tech, we're really fortunate. And there's a lot of power and responsibility that comes with that. And I say that to not, I don't want to dismiss how hard you all have worked and the obstacles you've overcome, but I think that these things all go together. You can be fortunate and lucky, and also work really hard to take advantage of the opportunities that you have. And so I think we need to use this well. So some better principles for AI, and these are the counter statements to kind of the misconceptions I listed earlier, are that we have a responsibility to think about the whole system and to recognize how our code and how our algorithms interact with complicated real-world systems. We need to work together with domain experts and with the people who will be impacted by our work. And we should ask, how can we best leverage the strengths of computers and humans working together for the best outcomes? So we have an example that regulation is possible and has been impactful in the past, both in how Facebook responded in a decisive and strong way to German law, as well as from other industries such as auto safety. We shouldn't be afraid of hard and messy problems in areas where there may not be, completely unambiguously clear answers. We can still find better solutions than what we have now. And tech has an impact on the world, and we have a responsibility to not just optimize metrics, but to reflect our values. Then I wanted to say a little bit about Fast.ai and how this fits in with ethics, and kind of how my views inform it. So with Fast.ai, we're trying to make deep learning more accessible and easier to use, and this is because I see deep learning is so powerful, and there are a lot of good things you can do with it. And I think getting people from more backgrounds will, people from different backgrounds know about different problems and come up with different solutions. And I think it can also be a check on the negative work that's happening, to have more people who can see misuses and hopefully help address them. I'm often asked if it's dangerous to have more people using AI, and I think it is more dangerous to just have an exclusive and homogeneous group alone developing tech that impacts everyone. So at Fast.ai, we have a completely free course of practical deep learning for coders available at course.fast.ai. It's taught entirely in Python, and this is something that I wish existed, 5 years ago when I was getting interested in this field. It doesn't assume any sort of graduate theoretical background, but is very, very hands-on, yet still state-of-the-art. We will be offering another in-person version downtown in San Francisco, one evening a week, starting up in October. And we're not just, or I shouldn't say just, but it's not only education, we also do research and incorporate that research into our course. It's state-of-the-art work. We competed in a competition earlier this year, hosted by Stanford. We were competing against teams with a lot more resources from Google and Intel, and we did really well and came up with the fastest on a single machine, fastest on a GPU, fastest on publicly available infrastructure. And then more recently, came up with the fastest distributed solution as well. And this is important to me, that it's not just people at Google and Facebook that can effectively use these tools, and that you don't have to kind of be in this elite crowd. I really want people from all backgrounds, and I mean that socioeconomically and geodiversity, and also just professional backgrounds. It's so healthy from the field to. For us in computer science to get people with different backgrounds who understand law and policy and education and medicine. We really need that, and we need those people understanding AI and what it's capable of. I wanted to list some more resources on these topics of ethics and AI. These are kind of 8 people that I deeply admire, and all of them have a lot of great work and articles and talks. To make it more concrete, I just chose one particular article or talk from each of them that you could start with. If having a list of so many people is overwhelming, I would say just start with Zeynep Tufekci at the top. But all of these people are doing really, really great and thought-provoking work in this area. So I hope you'll consider those. And actually, does anyone need to take a picture? Or should I leave it up longer? If we're good. Yeah, and so then I'm happy if there's time to take a few questions. And again, you can always find me online on Twitter at math_Rachel. Or on Fast.ai blog, I have an Ask a Data Scientist advice column. Thank you.
We do have time for a few questions. We've just got the one mic, so if you wouldn't mind, if you have a question, just come up and get behind the mic, if you would, quickly. And if I can lead things off. A question about something you didn't talk about. One thing that concerns me ethically is the lack of understandability in models. So the fact that we're making decisions, not just whether they're fair or biased, but we fundamentally don't understand how they work. Is that something that concerns you? And then do you have any practical stories? I feel relatively disempowered, say, to make decisions, because I'm a long ways from the decision about how the technology that I work on is actually used. Do you have any stories about people who are at the technology creation stage helping to make ethical decisions in big companies like Facebook, et cetera?
Yeah, no, those are both good questions. So the first question about interpretability, yeah, I definitely think it's an important area. I think that we can get explanations from black boxes, and just in terms of you can like permute the input data to see, like if these variables change, how do I get something, like how does that change the prediction, or finding what other inputs does the algorithm think that this example is similar to? Like what are kind of like the closest ones that are informing the decision? But I agree, interpretability is an important area, and I think that it's still very young. Like I think more research can be done there. In terms of, the problem of feeling disempowered or kind of, in a large company or even a small company of like, how much influence do you have? That's really tough. I think that it's helpful it's definitely helpful just even to be talking within your team and talking to other teams and trying to find other people that are on the same page as you within the company. That there can be like a strength in numbers or a strength in recognizing or even just identifying who else is thinking about these issues. But you're right that many decisions are getting made on a higher level. But I think kind of like maybe seeking out who else is on the same page as you is a good first step.
Cool, thank you.
Hi, thank you very much for shining a light on these topics. I really appreciate it. Just for all you data people who heard that there was a lot more Facebook people working in Germany rather than in Burma, there's a 3-to-1 ratio. So in Germany, 30 million people use Facebook, and in Burma, 10 million. So that number is clearly off by Facebook. My question is, what do you think, well, just a little bit of background. I was told by the head of NIAID, the National Institute of Allergy and Infectious Disease, to a room full of 60 PhDs and postdocs, you guys shouldn't get into politics because it will make you less capable of doing your work. What do you think as a computer scientist, as a data scientist, our role is in terms of politics?
Yeah, I think we do have a responsibility to be involved, so I disagree with that advice. And I don't know if that was intended as there are sometimes repercussions to speaking out, and I realize this also varies where you are in your career, that sometimes earlier in your career it can feel like there's more at risk of being seen as difficult. But yeah, no, I think a lot of the problems we're facing are really complex, and I think we've seen that we need more investment in politics and kind of need people from more backgrounds actively involved.
Thank you so much. That's a fantastic talk. I think you make a great point earlier that algorithms are frequently used to allocate scarce resources. We're frequently asked, there's only a certain amount of time or money that can be spent on this. How can we best sort of rank things? But I was wondering if you had any examples or any advice about trying to use algorithms to expand the resources that are available to attack a certain problem, or even sort of building on the last question about getting more involved in politics. But any examples or stories from that?
That's a great question. Yeah, so I just want to echo that point that it's definitely, yeah, sometimes like algorithms are being used when this underlying issue is that we just have not allocated enough resources to an important problem or an area where we need more resources. Nothing is jumping to mind as a positive example. That doesn't mean that they're not out there. The past year or two in particular, I have been struggling with feeling like a lot of the problems we're facing are not going to be solved by technology alone, and that technology can't replace good policy. Although I will share if I come up with an example.
Hi, thank you for speaking on this topic. Two things come to mind. One is data quality. For example, people now have the ability to challenge information in their credit history. Credit rating is very powerful, and I think that had to be fought for. And also, maybe you can speak to that or to outliers. If you're
To what?
Outliers.
Yeah.
You understand what I mean?
Yeah.
Data that's out in on the rim of what's expected, and also the humans. You could look at data and say that number doesn't fit. Let's check that, and are algorithms designed to do that kind of sanity checking?
Yes, I think, those are some good points. So, like this issue of outliers or sanity checking, I think it's really important to have like a process in place where it's easy to identify and correct mistakes. And so being aware that, we may hit edge cases or outliers. And so I think to kind of design your system in a way that, you have an easy appeals process, and also, to keep in mind, like we may need to update this, based on cases, and not to, like I think in the, when an algorithm cuts your healthcare article, there were some examples of people like referring to people that had lost benefits as like weird edge cases or something, but it's like they're people, so some of it I think is, having a tight loop around being able to identify and correct mistakes. The issue of data quality is huge. An example that I didn't use but thought about including, the LAPD put together a database of gang members. And this, and so a lot of people have done studies on network effects and who's likely to join a gang, and it was discovered by auditors that 42 people in the database were under the age of 1 when they were added, and 28 of those were coded as having, quote, admitted to being in a gang. Again, these are babies under the age of 1, and you think, there are groups that are going on to do research with this data and present it. There was a controversial Harvard computer scientist was presenting research, and someone asked about the ethical implications, and he said, "I'm just an engineer." But we really need to look at the data quality, because that can have a huge impact.
Thanks for your talk. I wanted to ask specifically about the meetup example you shared. You said that they noticed this issue with not recommending tech meetups to women, and they avoided the runaway feedback loop. Could you share how they approached that, or are you at liberty to disclose?
That's a great question. No, he does not in the talk give the details of how they did it, but I was wondering that as I prepared this, so I would love to know more about that too.
Hi, and
Hi.
thanks. I think I have a similar question, just like your examples of Facebook and Google and the runaway feedback loop. Like at the end of the day, that time on site is an easy number to sell. It's very easy to get ad dollars. It's very easy to get VC dollars. So how do businesses that are trying to sell that, what other metrics can you focus on, or how can you use machine learning to identify a better story to tell?
Yeah, that's a good question. So part of the reason I'm sighing is I do think there's an underlying, I just think a lot of businesses that rely on this personalized ad targeting model, I think is kind of fundamentally at odds with a lot of positive outcomes we would like to have in society, and so that can be And so I guess some of it, yeah, it's hard with yeah, like you said, it's easy to measure the time spent watching something, whereas a lot of things of like, I don't know, like how much someone learned from a YouTube video or how much they laughed, like those aren't even measured. And there's always a risk, and I saw this in data scientist, as a data scientist, like you often don't have the data you most want, and so you kind of have to like use the variables you do have. But yeah, I don't have a great solution to that. But it's an important question.
I was told I'm the last one. So regarding your data that you train models on, how do you handle misrepresented data? Or how do you fill the gap for an incomplete data set that you're well aware of, but it has to be implemented somehow?
So how do you deal with an incomplete data set?
Yeah, because my understanding is that most biases come from just like a data set that doesn't fully represent the population that you're trying to model after. Or is it more complicated than that?
I mean, I would say it's more complicated than that. But yeah, I don't know that there's like a solution of like this way of representing missing data is something that's going to address bias. I think that, there's a lot of research being done in this field. I would say I think it's really important to always be checking your outcomes and kind of checking if you have bias, and it's something that kind of no matter what positive changes you implement that you should continue checking, because I don't think it's a problem that's ever fully solved. But yeah, I'm not familiar with like a way of filling in incomplete data that addresses it.
Thank you.
Thanks.
Okay, so we are going to stop. Just one last round of applause to thank Rachel.